propellers driving this ship are designed to give maximum performance under any load condition. They are controllable pitch propellers. This film will describe hub maintenance procedure for the MSO and LST type ships. The most common symptom of hub wear is a sluggish blade pitch response. A slow and jerk indicates an even more advanced stage of hub wear. This sluggish response will necessitate a higher than normal operating pressure, as indicated on the hydraulic oil pressure gauge in the engine room. The second symptom that indicates hub wear is loss of oil from the gravity feed tank. The first step in hub maintenance is to confirm the need for maintenance. A minimum operating pressure test is the easiest method of establishing the effectiveness of your hub mechanism. Order full astern pitch. Once the ship has obtained full astern speed, order full ahead and check the time it takes for the ship's propellers to come to full ahead pitch. If an MSO of the 519 class can go from full astern to full ahead pitch in 8 to 12 seconds time with a maximum operating pressure of 650 psi, the hub mechanism is probably in good condition. For other class ships, check the specifications for the proper operating pressure. An LST of the 1156 class should be able to go from full astern to full ahead pitch in 8 to 12 seconds with a maximum operating pressure of 950 psi. A second way of confirming the need for hub maintenance is to examine the hub visually. Look for any sprung bolts, cracks, obvious oil leaks, a loose dunce cap or hub, or damaged blades. Based on the test and examination, the probable extent of maintenance work to be done on the hub mechanism is established. Yard services are then requested. The next major step in hub maintenance is to remove the hub from the ship while the vessel is in dry dock. This is normally done when a complete overhaul is to be accomplished. In-place maintenance can also be done with the hub on the shaft. Secure the hub oil system by closing the hub oil supply valve. Remove the drain plug on the hub and drain the hub oil into a container. Examine the hub oil for the presence of water or foreign material. If water exists, there is a leak in the system. And if foreign material is discovered, attempt to find its source. Unbolt and remove the rope guard. On the MSO, remove the two locking plates located on the front of the hub. Next, remove the two locking dowels located between the hub and the propeller shaft flange. On the LST, remove the protector plate located on the front of the hub. This plate is held in place by socket head bolts. Now, remove the hub locking keys on the LST. On both the MSO and the LST, dunce cap locking keys must be removed before unscrewing the dunce cap. Install the dunce cap wrench and unscrew in a counterclockwise direction. Remove the dunce cap and examine the inside for chips and filings. Check the O-ring contact areas for burrs. Remove burrs with very fine sandpaper. The blade removal is treated in another film. This spider or crosshead is held on the control rod by the control rod nut. Unbolt and remove the lock washer and unscrew the control rod nut. Disconnect the jaw bolt from the connecting rod by removing the jaw bolt pin. Remove the crosshead. The hub is now ready to be unscrewed from the shaft. Install the hub torque jig and take up on the clevis bolt. If hand pressure is not sufficient to break the hub loose, a small sledgehammer can be used. Unscrew the hub, reinstall the crosshead, and remove the hub to the shop for further teardown. Steam clean the hub thoroughly. The first step in hub teardown is to remove the crosshead by unscrewing and removing the jaw bolt nuts and shims. Replace nuts and shims on their respective connecting rods. Remove the blade seal ring and discard it regardless of its condition. On the LST, the wear plate must be removed before the blade seal ring becomes accessible. Remove the thrust ring locking pin. On the LST, the thrust ring locking pin is located in the after end of the hub. Remove the plug located in the center of the thrust ring assembly. Replace it with a spanner wrench stud. Install the thrust ring removal spanner wrench. Take up on the spanner wrench and withdraw the thrust ring assembly and its O-ring. Discard the O-ring. A new O-ring is installed during reassembly. Examine the threads and O-ring contact areas on the thrust ring assembly for burrs. Remove any burrs. Extract the crank pin. Remove the jaw bolt and connecting rod assembly. Lift the crank ring out of the hub. The same removal procedure for the remaining crank ring assemblies is followed. Be sure that the correct pitch adjusting shims are on their respective jaw bolts. Care should be taken during disassembly to see that parts are not interchanged. This will eliminate unnecessary adjustment and fitting during reassembly. Next, remove the crank pin and the wrist pin from each of the connecting rods. Exercise care to keep all pins and jaw bolts with the correct connecting rod. The hub mechanism has been broken down to its basic elements. The hub shell, the crosshead, the crank pin ring, the jaw bolt, the connecting rod, the thrust ring and bushings, the blade seal, and the O-ring gasket. Inspect the fit of the thrust ring bushing to the crank ring by assembling the thrust ring bushing with the crank ring. This fit is the most important single maintenance item on the hub mechanism. When there is too much clearance, the result is called tilt. Under normal operating conditions, when the bearing surfaces are properly fitted, a change in blade pitch can be accomplished with a minimum of operating pressure. When there is too much clearance between the crank ring and the thrust ring bearing surfaces, tilting occurs. The crank ring has a tendency to tilt in the thrust ring and trunnion bushings. Tilting increases bearing loads at certain places and results in a binding action. This binding action necessitates a higher than normal operating pressure for pitch change. Examine the bearing surfaces on the thrust ring assembly for undue scoring and wear. There should be 75% contact on the bearing surfaces, and the clearances should not exceed the maximum stated in the technical specifications. Measure with a micrometer the height of the thrust ring bushing at 4 positions 90 degrees apart. Place the crank ring on a precision surface plate and measure the height of the crank ring bearing surface from the precision surface plate at 4 positions 90 degrees apart. Compare these two sets of measurements to see if the clearances meet design specifications. If clearance is too great, adjustment or replacement is indicated. To check the bearing contact, coat the thrust ring bearing surface with bluing. Assemble the thrust ring with the crank ring and rotate. Then remove. And examine for areas where the bluing has been rubbed off. These areas are high spots and should be scraped or lapped down. If the area requires no more than 1/1000th of an inch removed, it is accomplished by lapping or scraping. Grinding is used to remove more than 1/1000th of an inch. Rebluing and fitting may have to be repeated several times before the desired fit is obtained. To ensure long bearing life, this bluing test is performed during every overhaul. Measure the bore of the connecting rod bushing at 2 positions 90 degrees apart. Record the measurements and measure the diameter of the crank pin at 2 positions 90 degrees apart. Record these measurements and compare them with those obtained from the bore of the connecting rod bushing. The clearance between the two should not exceed the limits set forth in the design specifications. Perform the same kind of check for the connecting rod wrist pins and their respective bushings. If they do not meet the design specifications, replace them. Examine the thrust ring assembly to see if the thin walls between the spanner wrench receiving holes and the edge of the ring are cracked or sprung. If any of these walls are damaged, they should be milled out so that the wall is eliminated. This completes the examination and replacement phase. The next major step in hub maintenance is to reassemble the hub mechanism. Install the keys and snap rings in each of the crank pin holes in the crank pin rings. Seat each crank pin ring in its numbered hub recess and insert the connecting rod through the aft end of the hub. Secure it to the crank ring with the crank pin. Install the new O-ring regardless of the condition of the old one. Replace each thrust ring using the spanner wrench. Secure the thrust rings with their locking pins. Seal by inserting a filler plug or pour lead over the pin. Scrape the filler flush with the surface. On the LST, the locking pin is inserted through the aft face of the hub. After the crank rings, thrust rings, connecting rods, and crosshead have been installed in the hub shell, it is ready for installation on the ship. Before the hub is screwed onto the propeller shaft, be sure to install a new O-ring on the forward end of the hub. Both hubs are screwed on in a clockwise direction. Install the hub torque jig. Apply torque by taking up on the clevis bolt in order to align the locking notches. Install locking plates on the MSO and secure them in place with socket head bolts. On the LST, install the protector plate and secure it in place with socket head bolts. Sealing compound is forced into the cavity between the protector plate and shaft. In both cases, lock the socket head bolts in place by punching the plate metal against the bolt heads. Drive locking dowels into the receiving holes between the hub and propeller shaft flange. They are called locking keys on the LST and must be inserted prior to the installation of the protector plates. Lock the dowels in place by punching metal over the edge. Install the crosshead. Be sure that the key is in place. Secure the crosshead to the control rod with the control rod nut and its lock washer. The installation and alignment of blades is covered in another film in this series. The dunce cap cannot be screwed in place until after the blades are secured. Install the oil drain plug in the hub. Install a new O-ring in the dunce cap. The dunce cap is the last item to be installed. Secure the dunce cap with locking plates. This completes the hub assembly phase. Open the oil flow valve at the gravity feed tank in order to fill the hub and shafting with oil. Place the shaft bleed plug in the up position and bleed out air. The final major step in hub maintenance is to perform the pre-launching hub pressure test. Build up about 15 pounds of pressure in the hub with the hand pump. With the blades static, look for any oil leaks, particularly in the shaft connection or blade seal areas. With the blades changing pitch, check for oil leaks around the blade seals. If no leaks are discovered, this completes the hub overhaul. Watch for these important symptoms, any one of which can indicate hub wear. Sluggish or jerky blade pitch response, which would necessitate a higher than normal operating pressure, indicates probable thrust bushing tilt. Tilting or binding of the crank ring inside the thrust ring bushing is the greatest single maintenance problem in the hub system. Loss of oil from the gravity feed tank indicates probable blade seal leakage. To ensure long bearing life, the bluing test should be accomplished during every overhaul. The hub mechanism will give long, dependable service if you will follow this basic maintenance procedure.